Ants are fascinating insects. They communicate with each other and coordinate both their actions and movements. Each ant makes its decisions autonomously, but in doing so is subordinate to the common objective, and thereby plays its part towards solving the task in hand. The delicate ants are therefore a real challenge for the Festo engineers when it comes to transferring role models from nature into the world of technology. For the first time with the bionic ants, the behavior of ants is imitated using complex control algorithms. In this respect, it's not about a technical game for the Festo engineers, but about nothing less than the production technology of the future. In the world of Industry 4.0, machines also have to communicate with each other, make autonomous decisions and cooperate in order to be able to react flexibly to different production scenarios. The biggest challenge for the Festo engineers was to integrate all the necessary functions of an artificial ant into the smallest of spaces with as few components as possible. Our engineers overcame this challenge. Enough space was created for the rechargeable battery, and room for the eyes was made in the ant's head. Such a functionally integrated design is made possible thanks to 3D printing. It would be difficult to make such an ant using conventional production engineering. 3 piezo bending transducers are used on each leg. Coated on both sides with piezo ceramics, they are able, depending on the electrical controls, to deflect by 1.5 millimeters in both directions. Clearly not enough to get an ant to walk. With the help of an elastic hinge, the Festo technicians have managed to increase the ant's step length to over 10 millimeters. The benefits of piezo elements are impressive. They work on little energy, are almost wear resistant, and can be controlled quickly. But how does a small ant robot learn to walk? The motion sequences of the ant are programmed and tested on a computer. If the ant walks smoothly on the computer, it must demonstrate during initial tests on the real model how well it can walk with its 6 legs. Taking into account that this bionic ant has only just learned to walk, it gets around really quickly. Using a 3D camera system, which was developed by scientists at Delft University and adapted to the ant by Festo engineers, the ant is able to see. Combined with an optoelectrical sensor, the bionic ant manages to find its way round in the space. How does the ant determine its position when it's on the pitch? Well, for this we actually use 3 sensors. First of all, we have a mouse sensor here under its abdomen. The mouse sensor is actually the same as in a computer mouse. We can use this to track where the ant walks across the pitch. We also have a magnetometer here in its head. The compass actually shows where north is, and with this we can determine what direction the ant is headed. Here at the front we also have a camera system consisting of 2 cameras, which gives us a stereo image and means we can detect the markers on the pitch and also measure the distance to them. We can therefore position ourselves with complete accuracy on the pitch.